Swayam Prabha. Digital India. Educated India.
Okay, so we will work out some more problems on view factors today, and hopefully today or tomorrow we will start the radiosity radiation method. Okay. So we will specifically solve two problems which involve the use of the charts, right. So essentially you have to use charts for 3-dimensional geometries. If you recall, we started off with simple 2-dimensional geometries wherein we used algebra or simple rules like summation rule, reciprocal rule, okay, and then self view factor equal to 0 and all that, and then we algebraically manipulated and got the view factors. Then there are problems in which you have to use first principle integration, that is you have to integrate from first principles and get the view factors. So we chose a simple problem where it was from an infinitesimally small disk, infinitely small area to a cylindrical disk, it was easy. But if both were finite areas, then we have to make it dx1 dx2, you have to use double integral strip and so on, right. And some people have developed techniques between two parallel rectangles, between two perpendicular rectangles, between two coaxial circles and so on, concentric two coaxial disks. So people have developed this integration and they have presented the results in the form of charts as well as tables. I did not give you the tables, I have given you the charts. They are, the accuracy is somewhat lower for the charts, but it is okay for this course. If you want to actually solve problems involving radiation and all that, you can, maybe you can use the tables or you can write the program yourself and subdivide each surface into elemental surfaces and calculate the view factors. Now I have given you charts in which there are basically 3 charts, one is perpendicular rectangle, parallel rectangle, and then the parallel disk, okay. So we will now solve 2 problems, one involving perpendicular rectangle, parallel rectangle, no equal area, no, the base must be with a common base, the base must be common, but the area of the one need not be equal to area of 2. Yeah, so it has a common edge, it has a common edge. Okay, I got what you are saying. The chart cannot be used for this. Of course we can do something, we can again subdivide and this thing and do all sorts of permutations and combinations. Basically they will have a common edge, okay, but A1 need not be equal to A2, right, there is no requirement. So from the charts you will get only limited number of view factors, you will have to use repeated algebraic manipulations, you will have to do repeated algebraic manipulations, and in the quizzes and exams you have to be really fast, somewhere some trick will be involved, okay. So I will ensure that some trick is involved, otherwise we will go round, okay. So that smartness also is required, so in using this, right. Of course as the computer gets more and more powerful, all these things will be relegated to the background. Whatever we are doing today, I may not teach it after 10 or 15 years, just like I am not teaching Bessel function and all that nowadays, okay. Bessel function, all this is not required, you can write your code in script in MATLAB and solve some equations and get the fin profile and all that. Otherwise variable area fin, we used to have Bessel function and solve it, and okay, fine. Now what is the problem number 30? We have finished 28, 29? We did not do. What was 29? F14, you take it as homework exercise, we will go to 30. F14 was what? No, I will not do that, I will go to some other problem. Then I have to teach the whole one full semester on view factors, okay. So No, I am having trouble. Okay. So, we will do the same F 1 2 3 4, but now 1 is here, 2 is here, 3 is here and 4 is here. Okay, this is the common edge, they are perpendicular. I will give you the dimensions. I have not drawn it properly. Okay, I can still. This is 1.5 meter. Okay. So, the question is get F12. Okay, the problem can read like this: consider the configuration shown in the figure. Consider the configuration shown in the figure. Two parallel rectangles with a common edge. Each of these rectangles is further subdivided into two rectangles, so that we have 4 areas A1, A2, A3, A4. Get the view factor between 1 and 2. Get the view factor between 1 and 2. Please start slowly. A good strategy would be to first write A1, A2, A3, A4 and then A24 and A13. Write the 6 areas first. Okay. Then calculate all the view factors which can find out all the view factors which can be determined from the chart. Okay, and then start your algebraic manipulation. The other risky route would be disregard completely. F1 2 3 4 is equal to F1 2 3 F1 4, you keep on doing till you get an expression for F1 2 in terms of all the other things, and then substitute A1 A2 A3 A4. This is high risk from a student perspective. Okay, it is better to just list out first the areas and list out all the view factors. At least the teacher knows that you know how to read the charts, how to get the basic view factors. Then you can start off with your algebraic manipulation. Okay. We can also pose the question is get a general expression for F12. Okay, I need not tell you the areas. Get a general expression for F12 in terms of A1, A2, A3, A4. Okay. So, I will start in parallel. Please do not look at the board, you keep doing and then we will see whether we get convergence. So, A1 is A1 is 7.5 meter square, A4 is also equal to 7.5 meter square, A3 equal to A4 is also equal to 17. Latecomers, we just started on a view factor problem. It is self-explanatory. A13 equals 25 meter square, very good. A24, okay, fine. So, we listed the 6 areas. So, the easiest view factor to get is F13 to 24, okay. We can get it from the chart, okay. So you have to, so on this chart, so please take y by x and z by x, please take y by x and z by x. Now okay, y by x is 1, z by x is also 1, okay. F, so from the chart you please read off from the chart, what did I get? I got around 0.2, is that okay? Is it the same as F24213? Yeah, okay. So we have just started, we are far off from the final answer, okay. This is just warming up, a lot of algebra is involved, okay. F13 to 24 is fine, so far so good. Let us keep this fellow here itself, whatever we obtain we will write here, right, okay. F we will keep the figure intact, we will also keep these areas intact, we will keep working on this side of the board. A view factor problem like this would be 20 minutes, 15 minutes if you are very fast, 20 minutes is a reasonable time. You after finishing you can check it also, right. Now what is the next thing? Now before doing the algebra we can get F14 from charts, correct? F14 can be obtained, right? Yeah, y by x equal to z by x equal to point 0.12. Is F14 the same as F41? Yes. Yeah, go back here and write. Let us also calculate F34. Yes, F32. Huh? Yeah, okay, F23 you want, right? We will write F23. No problem. Okay. Y by x 1 point. Same. Point 17. Yeah, we will do it slowly. 30 to 40% is over now. So regardless of the difficulty level of the problem, all of you can do up to this stage, right? No great this thing involved, right? So if you do it systematically, and at least we will know that you are able to follow. For F23 equal to now the manipulation will start. You have to apply the reciprocal rule and the decomposition rule. So it is just the manipulation of reciprocal rule and decomposition rule, nothing else. Some rule will not work because it is not an enclosure. Okay. So this reciprocal and decomposition rule repeatedly you have to apply, use your common sense, and then we will have to crack the problem. Now fine, we have got these basic view factors. Not even one more view factor you cannot get from the chart, that is it, over. The use of the chart is over. Now the chart can be relegated to the background. Now you have to start working on that. Fine. Now we do not know where to start, so I will start with F. No, I will start with F. Okay, F2213 is fine. F okay. What did we get? F2213 was we can't get. Okay. No, wait, no problem. No. F132 also we cannot get. Okay, no problem. What did I do? F132. F1324. No, let it be like that. We can't do anything with that. Okay. F132. No, F1324 is equal to F1322 plus F1324. Now we can do something with this. Left side is 0.2, you know, right? F1324 is 0.2, we already got. Therefore, from the first one F2 to 3 is known, huh?
F212 plus that is not common, no?
Yes sir, now you have to reduce the reverse solution.
What is your problem?
Sir, 2 to 1 the decomposition.
No, this is correct.
From common area you have to give.
I already proved in the last class. If you take F1322, you can't write it as F12 plus F322. If it is going from 2, it is okay for us to write F2 to 1, F2 to 3. We already done it in the last class. But the converse is not true. You can't split F13 to 2 like this. Then it will be A13 F13 to 2 is equal to A1 and okay. From 1 yeah, we have F2 to 3, isn't it? 0.17, correct? Okay. Now I will try to link these two, it is possible, right? Because A2 F213 is equal to A3, sorry, A2 F13 is equal to A13 F13 to 2, right? Okay, so we will get rid of the figure now. Just to avoid being misled, I will just have it, huh? Which is 1, 2, 3, this one, huh? 2, okay. Now A2 F13 okay. Now what is A2? What happened? We didn't write A2? Huh? No. What is A2? Okay. So 17.5 F2213 equal to 25 F132. Therefore, F1322 is equal to 0.7 F2213. That is equation number 5. Okay. We may finally get only F21. If I get F21, I can go home because A1 F12 is equal to A2 F21. Okay. Now F41 to 3 is equal to F4 to 1 plus F4 to 3, correct? And this is 6. As far as F4 to 1 3 is concerned, I am having F13 to 4 here, and the relationship between F13 to 4 and F4 to 1 3 is so straightforward, reciprocal rule. Okay. So A4 so 7.5 is equal to 25. Now I can remove this. Okay. So F so this I will call it as 7. So I substitute for F13 to 2 and F13 to 4 into equation 3. Okay. So 0.2 equal to is that okay? 0.7 okay, plus what did I do? Plus 0.3 into 0.12 plus, correct. Okay. No, we have to be careful. F34 equal to F12, that is the killer step. F34 equal to F21. F34 equal to F21. It is the same 90 degrees. This fellow is 3.5 into 5. Okay. This fellow is 3.5 into 5. this fellow is 1.5 into 5, this fellow is 3.5 into 5, this fellow is, unless you make this common sense this thing, this problem cannot be solved. F1 F2 you will keep on doing, okay, that is where you reduce the number of u factors by 1, okay. Now but the critical step now is but F34 equal to F21. So shall we give a name to this? Law of corresponding corners. This is called the law of corresponding corners. Okay. It is important to give a name so that you do not forget. Okay. Now you can simplify. So I told you it will take 20 minutes, right? Okay. On simplifying, what do you get, Vikram? F12 or F21? Yeah, I also got F21 I think. F12 equal to F43, F12 equal to F43, correct? If you get 0.06 or 0.08 it is okay, but if you get 0.7 or 0.6 it is wrong. There may be some small differences because when you read the chart there may be some small, and the error will be more if the view factor is smaller, okay. So you can see with 4 surfaces it takes 25 minutes, okay. Now Kamath, you are convinced? He was not happy that F213 we put it as, if there was any mistake there we would have got F is negative, it would have been a fatal flaw, okay. Now of course your Fluent software can handle all this, you can divide it and it will get S to S, it can get the view factors, it will do the contour integration and get the view factors, but still if you have a n number of surfaces where n is only 3, 4 or 5, you can still do these hand calculations. And is this clear? Yeah, let us go to the last problem on view factors, okay. So problem number 31, please take down this problem. An enclosure is in the shape, problem 31, an enclosure is in the shape of a frustum of a cone, an enclosure is in the shape of a frustum of a cone. That is a slice of the cone, not the full cone, okay. Lot of people think it is frustum, it is frustum, R is not there, you can check up with the dictionary. Huh? The frustum of a cone, the dimensions of the enclosure are given in the figure. The dimensions of the enclosure are given in the figure. Figure will follow. Dimensions of the enclosure are given in the figure. Determine all the view factors. Okay. So, this is the enclosure, this is surface 1, this surface 2, this is surface 3. Outside there is no activity, the whole thing is hollow, so radiation is taking place inside. Let us not worry about the emissivity temperature, that will follow after we learn radiosity and irradiation method enclosure analysis, we will solve for radiosity and get the heat flux, but now we are interested in the view factors. Now this height is now 5 meters and this is about 3 meters. This is about 4.5 meters. If an enclosure problem is given, it is a good idea to first state how many view factors are to be determined, how many sum rules are there, how many reciprocal rules are there, how many self view factors are there, then find out how many view factors are to be independently determined. Then you will get an idea whether you have to use the chart or by manipulation, because sometimes you are confident or even overconfident that by just algebraic manipulation we can get the view factors. Now how many surfaces are there? 3. Total number of view factors? 9. Okay. N sum rules, reciprocal rules, self view factors, total. So one view factor has to be independently determined. Fortunately that one view factor is this fellow, for which I gave you the chart. You determine that fellow and then using your view factor algebra and other relations get all the view factors. Okay. Now hence for those rectangles and corresponding corners you do not have to apply this. This algebra applies only for enclosure problem. Okay. So we can get that from the chart. Okay. So if you look at the chart, so the chart is given like this. Okay. So view factor for coaxial parallel disk. Okay. So Ri and Rj are the radii of the two respective disks and the height is given as L, that is a separation distance between them. Now you have to use the charts and get this. Okay. Now So we can get F12 from the chart straight away now, correct. Now R1 therefore L by L equal to L by Ri how much 2.22 Rj by L okay. So based on this, based on L by Ri, based on L by Ri and Rj by L, based on L by Ri and Rj by L, you can straight away get the, how much did I get? I got a 0.08, 0.07 huh? Okay, no problem. F12 okay. So the first view factor we got, what is F11? 0, correct. So we got 3 view factors now. We have solved for all the view factors for the first surface. Likewise second surface also we can do, but when you come to third surface we are in trouble. Okay, it is only a minor trouble. Okay, A1 F12 okay. So this F21 is even smaller, huh? Is it? Which one? Oh, R1 is more, no problem. Okay, F21 is how much? Point? Let me see. F21, I didn't calculate at all. Or? Okay. F21 plus F22 okay. F22 equal to 0, therefore F23 very good. Six view factors are over. 6 huh? 6 view factors are over. Now we can also go a little further. Left side is completely known. A3 is not known. A3 you have to find out from your fundas, from your knowledge of geometry. Please do it. If you get A3, you can straight away get F31 and F32. Once you get F31 and F32, F31 plus 32 plus 33 equal to 1, F33 is 1 minus F of 31 minus F of 32, then it is over. Okay. In order to get this, okay. You have to connect. So this is what is this? Okay. Now I call this as x, okay. The law of similarity triangles, x divided by 1.5 is equal to x plus 5 divided by 2.25, is that correct? Okay, x divided by 1.5 is equal to x plus 5 divided by 2.25. Vikram, is it okay? Now, so 2.25 x x equal to 10, huge. X equal to 10 meters. Okay. Now, the surface area of the cone is pi r L, where L is the slant length. So you have to find out the slant length now. Okay. So L is the slant length. Okay. Now there are some fundas involved, it is not the full cone. So pi RL of the big one minus pi RL of this will give the pi, okay. So you can take it as pi R L2 minus L1, no pi R1 L1 minus pi, correct, okay. Okay, so L equal to root of 225 plus 2.5 square, is that correct? 15.
15 square is 225.
Yes, sir.
How much is it?
15.17.
So let us call this L1, and this fellow is L2. L2 equal to 25, sorry 100. No 10.1, therefore what? No 2 pi R. What 2 pi R?
The circumference perimeter will be 2 pi r.
Half base
No,
into
no.
half base
It's pi RL.
Pi RL is cone. We can derive it if you want, but that is not. Which one? Which comes out to the same? That is only correct. Huh? 2 pi RL.
Sir, you take the area of the triangle and do it, sir. It will come the same. Half base into it will come 2.
What is the 2 pi RL? What I have done is correct. Okay, there is no. Okay. Now A1 F13. What is A1? What is A1? 15. 15.9 into F13 was. What is F13? 94. F31 point, okay, very good. Similarly, A2 7 point, F23 F32 equal to 0.1. So finally you have to put the solution like this, which can be entered into a computer program if you are doing the enclosure analysis, okay. Because it is 3 by 3 you are able to do it with hand, if it is 10 by 10, 20 by 20 you will write a program to determine the view factors and store it once and for all. Then when the temperatures are dynamically updated, this fellow will not change because this fellow is a function only of the geometry. However, if you have a problem in which the surface is also changing, the dimensions are changing, which can happen if you have an ablating surface. A re-entry vehicle enters the Earth's atmosphere and because of ablation, so few millimeters of the surface is getting evaporated, sublimated away, then the geometry will change. So geometry linked view factor calculations will be there, that is the state of the art. That is the state of the art if you want to do radiation calculation at a level which will make it journal worthy, okay. Right, now as far as our problem is concerned, so point not 8, no 0, point yes. This is a decent enough view factor problem. So we just solved 2 problems today, that is quiz. I will ask 3 questions okay. So this is the difficulty level, this is the difficulty level with the classroom environment. When you actually solve your problem for a project or research, it will be much more complicated. People have thousands of elements, and in fact in convection solvers you have millions of elements. And the radiation is, people normally do not update radiation in the every iteration, because convection is radiation is well behaved compared to convection. So once in 10 or 20 iterations of convection we will stop and do the radiation calculations and then proceed. Even though it is t to the power of 4, you think it is non-linear, the convection is u dou t by dou x or u dou e by dou x, E is terribly non-linear compared to this, okay, the convection, the advection, because it is very direction dependent. If it is a recirculating flow, if the direction changes, then the u, v, all that will struggle to converge, okay. So we will stop.